Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial, and we have specific processes under specific results. Then we end it. Let's start with this polynomial. We are given with this quadratic trinomial here, and we are tasked to factor this. This is considered as a quadratic trinomial because of 3 terms and the decreasing order of the exponent of the same variable x. We have x squared, then we have x for minus 7x, and we have plus 6, a constant which can be paired by x to the power of 0, which is just equal to 1. So to factor any quadratic trinomial, we need to check first whether this is a perfect square trinomial. And if it is, then we proceed with factoring a perfect square trinomial. If it's not, then we proceed with another method. We can verify by identifying these 2 conditions. If these 2 conditions will be met, then definitely this given of ours is a perfect square trinomial. The first condition is that the first term and the third term should be a perfect square. Our first term is a perfect square of x. That's x squared. So it meets the criteria here. But our third term is 6. And 6 is not a perfect square of any integer. So we could say that just for looking at the first condition, this trinomial of ours is no longer a quadratic, it's not a perfect square trinomial, and we are going to proceed with the second method. But just in case you will say it's a perfect square of square root of 6, because the square of square root of 6, when you take the square of it, you will get a result of 6. So let's just in case, just for the purpose of going further to the second condition, let's just say it's a perfect square. And let's say that the first condition has been met. Let's notice this second condition. The second condition is where the second term must be a result of 2 times the square root of the first term and times the square root of the third term. If our middle term will satisfy this condition, even if we have assumed earlier that 6 is a perfect square, then we will accept this is a perfect square trinomial. But even if we accepted the first condition, let's say 6 is a perfect square, but it will not meet this criteria, then that's a further proof that it's no longer a perfect square trinomial. Let's check. Our second term is minus 7x. Let's see if this is a result of 2. The square root of x is x. The square root of 6 is, we have here square root of 6, right? Square root of 6, that's the root of, if we consider 6 is a perfect square. Don't forget that if we're going to take a root of numbers, we will have plus minus. So we have minus 7x. Is it the same as when we multiply? We have plus minus 2 square root of 6x. As you can see, even if it's plus or negative, this will not be true. This is again a further proof that our given is not a perfect square trinomial. Again, I'm just showing you this second condition just in case we also, because 6 is also, may also be a perfect square, a square of a square root of 6. So again, this is not a perfect square trinomial. In factoring a trinomial that is not a perfect square, we will use the AC way, or AC method. AC means we multiply the A and C coefficients of the trinomial. A here is the coefficient of your first term, so you have 1. And C is of course your constant, 6. When you multiply 1 and 6, you will get a result of 6. The next part of this method is we need to look for factors of 6, any factor that you could think of. Of course, the first factor is 1 and 6. You could also pick 2 and 3. Even the negatives, negative 1, negative 6, and negative 2, and negative 3. By the way, we are now on AC way. or AC method. This is to be used when our trinomial is not a perfect square trinomial. Now, these are all pairs. We have 4 pairs of factors that when multiplied by their partner will result to 6. Let's try to add all of this. Okay, let's add. The certain pair that will result to our middle term, which is minus 7, is the item that we're looking for. 1 plus 6 is positive 7, so it's not. 2 plus 3 is 5, so it's not. We're looking for this set of pair. Okay? Because the last one, negative 2 plus negative 3, is negative 5, and it will not result to negative 7. Here, negative 1 plus negative 6 is negative 7. And negative 1 times negative 6 is your AC. These are the coefficients you'll be using here, because the factor of any quadratic trinomial is a pair of binomial expressions. So this is how we do this one. Square root the first term, x. You also have x here, right? And then you will write these two coefficients. So negative 1 or minus 1 and negative 6 or minus 6. Now these are the factors of x squared minus 7x plus 6 using AC way or AC method. Again, the AC method, multiply A and C coefficients, the result, look for factors of that result, and then look for those pair that when added will result to B. If there can be none, that would mean your trinomial is non-factorable, and you will stay that as a result, meaning it's no longer factorable. But in this case, these are our two factors, x minus 1 and x minus 6, but still, we started with identification whether this is a perfect square trinomial or not. The next factor we're looking for is for our next subscriber. Subscribe now!